All right, we are live a minute early, but thank you to those of you that are on already. Just wanted to make sure everything's good. We are live on YouTube, Twitch, Facebook, all social platforms. I see one of us is already here. Beautiful. We will get started shortly. I'll wait 20 more seconds here until 5 o'clock hits. Well, welcome everyone that's already here. If you can hear me, put a plus in the chat for me so I know you can hear me. That would be very, very helpful. That would be very helpful. All right, well, today's lesson is on estimation. You're in the right place. Hi, Raymond, welcome. You're in the right place if you're here for pre-algebra, free lesson. We're talking about estimation today, same lesson as last week, but I know a lot of you missed last week. So here we are again, talking about estimation, a super powerful tool and concept and skill that we learn in pre-algebra that many math teachers in school actually skip because they don't find the need for it. But I think it's very, very powerful tool, especially for mental math and later on just building these foundational habits and skills. So welcome everyone. If you want to access today's workbook, it'll be the first link in the YouTube video description. You can go ahead and check that out. Yes, Raymond is modding for tonight. Thank you, Raymond. Welcome. Before we get started, if you want to take that URL at the top of your browser, copy paste it to any group chats, any friends that you think would benefit from tonight's stream, any family members, go ahead and bring them on in before I introduce myself. All right, let's get started. I'm Eddie Kang. I've been teaching for 9 years in high schools and colleges. I got really good grades myself. In school, I got all A's in math, a perfect score on the SAT, 5s on my AP exams, and eventually got into my dream school, UCLA. After graduating from UCLA with a pure mathematics degree, I started teaching right away and quickly found that I'm super passionate about teaching math. And that's what I'm here to show you tonight. Hopefully, my passion is communicated through your screen tonight. And it shows. My passion has showed, and I know that I'm getting better at it as we go because my students have gotten into the top national universities or top universities in the nation. They've gotten 5s on their AP exams, perfect scores themselves on the SAT, and just, performing above the national average in almost every metric. But most importantly, they had fun doing it. And I'm here to show you tonight that learning math could be fun. It doesn't have to just be all about memorizing stuff, but math should be understood, right? It should be understood. We should know the why behind why things happen so that we can use them and not just memorize formulas and memorize when to use them. That's not what math is about. It's about truly understanding the mathematics behind everything. Hi, Zong, welcome. So let's get started. I love starting up my lessons with something called a vibe check. So why do we estimate? In the chat, I see we are all over from YouTube, Twitch, and Facebook tonight. Love it. Why do we estimate? In the chat, let me know, why do you think we estimate? Why is this a thing? Why do we estimate at all? Like, why is it even a thing? Estimate. What does estimate even mean? It's like rounding almost, right? Yes, we're also live on Twitch right now. We are live on, I believe, my Space US. So you can check that out on Twitch as well, and I'll be able to see your chat. Olivia, welcome back. Good to have you back. Zong, I think I've seen you before as well. No worries. We're just getting started. Olivia, I think you've already been through this lesson before, if I'm not wrong. I think you were here last week as well, right? The question is, why do we estimate? Yes, I remember y'all. I always remember my returning students. I think that's one of just like a skill that I've been able to nurture throughout my teaching career. I do remember names pretty well. For those of you that are new, don't be shy. I say this every lesson, but when you participate, you're truly learning. So, It's just a great thing. Hi, Jenny. Welcome. Replying to EddieDoesMaths. Yes, the Facebook account that I was graciously given access to is Neil's. Neil and I are very good friends now. He's been helping me a lot as well, coaching me. He's the GOAT. Yes, Olivia, you always get a shout out. All right, well, why do we estimate? Let's get into it. Let's get into today's lesson. Let's get our gears running again, our brains activated, because right now it is 5 p.m. on the West Coast, but I believe on the East Coast it is 8 p.m. Eastern time. So it is a little bit later, and we want to get our brains activated again for today's lesson. So why do we estimate? The main reason is to save time. Exact calculations can take a long time, even if we have calculators. Oftentimes when we have multiple operations that we're working with, using our minds, using our brains, super powerful muscle, by the way, the most powerful muscle on planet Earth, we can calculate very quickly and estimate bigger and larger expressions into calculations that are really, really close to the exact calculation. Estimation is quick and gives us a fast idea of the answer. So let's get into our first example here today. In 2022, roughly 1,526 flights landed. That's a lot of flights and took off. Sorry, landed and took off from LAX per day. Wow, over 1,500 flights landing and taking off from LAX. LAX is the airport from Los Angeles where I am based. Estimate the total number of aircraft operations at LAX in 2022. Ooh, okay. So in 2022 means we're working with 365 days. And here we have the per day, 1,526 flights. So now, what we would do to estimate the total number of aircraft operations at LAX in 1 year, in the year 2022, we would go 1,526 times 365. However, this is going to take a long time. Even if you were to take this into a calculator, chances are you may make a mistake as you're typing this up, or we can, it might just take a long time just pulling out our phone, right? So instead what we do is, what do you think we would estimate 1526 into? What would you estimate 1526 into here? 1526. What is a nicer number than 1526? And also for 365. So again, this is our very first example, but by the end of today's lesson, you're going to get so good at this, estimating, rounding, and just like getting really quick calculations, and your mental math is going to grow a lot over the course of this lesson as well. Yes, so 1526 we can round to 1,500. Let me make sure. We have 1,500 times, and 365 we can estimate to 400. And now let's multiply. 15 times 4 is 60, and we have 1, 2, 3, 4 zeros. So 1, 2, 3, 4. Great, Zong. So we have 600,000. This is our estimate. 600,000 is our estimate for the total number of aircraft operations at LAX in 2022. Let's check what the actual number was. 556,913. This is a pretty good estimate, right? We're off by 44,000, not too bad, or about 43,000 if you think about it, because 913 will round up to 1,000. But what we can say here is we can do, all right, well, 1526, 1,500 is less than 1,526, but 400 is pretty significantly greater than 365. So we know that 600,000 is an overestimate of our actual number. So we can say, our estimate is going to be an overestimate of the actual number, but we're still going to be pretty close to what the actual number is, right? Because in this case, we're probably not looking for an exact number anyway. We're just kind of estimating roughly, right? Even the 1526 is an estimate itself. So roughly, right? We're estimating here. By the end of today's lesson, you're going to be masters at estimation. Let's try another one. A more applicable one here. You're at a local supermarket with $25 in cash. Your basket has items priced as such, 4 items. Do you need to calculate the exact total, or will an estimate be good enough to check if you have enough money? What do you think? Without having to solve this yet, what would you do if you're at the local supermarket or convenience store, you had $25, you had 4 items, and you know each of these prices? Do you think an estimate is good enough, or do we actually have to calculate the exact amount to see if we'll be able to purchase all 4 of these items? What do you think in the chat? Is an estimate good enough, or do we want the exact amount of money? Don't be shy. Also on YouTube, if you want to chat, you might have to subscribe first. You might have to subscribe, then refresh the stream or refresh the site, and then you may be able to um, participate in the chat. Yes, Olivia, estimate would be enough. And I love that, Olivia, you put that little question mark because, sometimes we're not sure, but I love that we're trying, right? The research shows that when you make a mistake and you fix that mistake, or when you have a thought and you confirm that thought or fix that thought, that's when true learning occurs. And that's what's important, right? That's true learning. And that's what I like to focus on in my course. So yes, estimate. Let's estimate. $3.99 is the same as 4. Oops. $3.99 is the same as 4. $2.79, let's call 3. $4.49, let's just round up to 5. And $8.50, let's round up to 9. And let's add these up. When we add these up, we get $21. And we have $25 in cash, so 21 truly is enough, right? 25 will be able to afford all the items in our box, in our basket. Okay, now, an engineer is calculating the weight a bridge can safely hold. So here's a little bridge. Let's have fun with this. Here's a little bridge. I don't know what a bridge looks like, but let's say, this is a bridge. And we have, cars going across this bridge. Boom, boom. Cars on either side are going across this. This is the bridge for those of you that are not liking my drawing here. Tried my best. So it's rounding up. So we can round up, we can round down, but because we want to know in this case, do we have enough? In that case, we do want to round up. Great question, Zong. All right, so let's say cars and buses are going across this bridge, but they have different weights and the bridge needs to support many vehicles at once. If you were the engineer, would you estimate or calculate exactly the amount of weight a bridge can safely hold? What would you do? Would you estimate or would you say exactly how much the bridge can safely hold? On a bridge, you don't know what type of vehicles are going to go on. You know there are going to be cars and buses, but at one point, there may be just a few cars. There may be just a few buses. There may be all buses. There may be all cars, right? We don't know that for sure. So if you were the engineer, would you estimate or calculate exactly the amount of weight this bridge can hold? Up to you, right? Just want to know your thoughts in the chat. What do you think you would do? And then I'll let you know what I would do. Not that I'm correct, but a suggestion nonetheless. Should the engineer estimate or calculate exactly? Cars and buses hold many people. So yes, I agree. I think we should estimate and round up, just like our previous example. And that's why when you get into an elevator, the next time you're in an elevator, look at the capacity, the max capacity in an elevator, and you can see how much weight the elevator can hold. It's always a whole number, right? It's always it's like 10,000 pounds or something like that. And that's an estimate, right? It's not an exact amount. Sometimes if you go slightly over, it might still be able to function. If you're almost at 10,000, it might even break, right? So it's an estimate. It's an estimate, but we're always rounding up. Or in the sense of capacity, max capacity and weight. Here, let me write down weight as well, since we're talking about weight. We might want to round down as well to be safe. Let's say we do all the calculations and our exact number, let's say, for example, is like, I don't know, 9,276 tons. This is how much the bridge can hold. But what would we write? We would tell the engineers to say, okay, we estimate it can hold about 9,000 tons. And we're playing this safe, right? Because it can actually hold 276 more tons, but we want to play it safe and say, all right, let's round down to 9,000, right? So depending on the situation, the way that you round will be different. And that's what we're going to practice today. All right, let's take a look at this one. To estimate / approximate answers to a calculation, we round our figures to one significant figure. It isn't an exact answer, but as we have seen, the solutions are close, scary close, like our LAX question and our supermarket question. Approximate each of the following. So letter A, we have 49 times 82. What would you estimate either of these numbers to? And when we estimate, we don't use the equal sign. We use a little squiggly. So for 49 and 82, what would you estimate or round these numbers to? 49 and 82. 49 looks really close to, yes, exactly, 50 times, and the 82, we would round a little down, right, to 80, correct. Now, 50 times 80, 5 times 8 is 40 with the 2 zeros tacked on. So now we have 4,000. 4,000 is our estimate to 49 times 82. Great, Olivia, I see you in the chat. Now, 49 times 82 is actually 4,018. 4,000 is awfully close to 4,018, right? Just goes to show that estimation is really powerful. We don't have to just pull out our calculators all the time. Sometimes estimating can get us to a really close answer. Yes, Olivia, 4,000, amazing work. Now, for letter B, we have 398. We want to estimate that to 400. 612, we will estimate that to 600. And 203, we're going to estimate to 200. And when we add these up, this gives us 1,200. And the actual answer to this is, I believe, let's see, for 12, we're 1,213, which is, again, really close to our estimate, right? But we didn't have to do any of that extra mental math. We just had to estimate it to one significant figure. One significant figure meaning we have just one whole number and the others are zeros, right? And that's one significant figure. Easy way to estimate and get to our answer quickly and pretty accurately, right? It's a very good estimate. Now let's try letter C. Letter C says 2,981 divided by 49. What would we estimate either of these numbers to one significant figure? In the chat, let me know. I'll give you a couple seconds here. Now that I've modeled a couple of these, Olivia's been participating, so has Zong. For those of you that are new, feel free to participate. Don't be afraid to make mistakes. When you fix it, when you make a mistake and you fix it, that is true learning, right? That's what we love to do. So 2,981, what would you estimate that to? And then 49, what would you estimate that to? Olivia's too quick for us. 3,000 divided by 50. Yes. And now tens cancel out. 300 divided by 5 is 60. And that is awfully close to what this will be. I believe it's something like 58 point something, but really close to 60. And we got this answer way faster than any of you would have gotten it by plugging this into a calculator. Great, Gibby. I see you as well on Facebook. Captain Jokovic, great as well. Awesome work. For those of you that are curious as to how I'm responding to everyone, this is the little stream. Oh, it says new comments will display here. Yeah, I could see everyone's from different platforms as well. So it's really cool. So just to give you a little look at what I'm seeing. Okay, let's keep it moving. Let's make it more challenging. Every slide that we go through, it's going to get a little bit more challenging bit by bit. And that's what's exciting about my lessons. All right, approximate each of the following. How would you rewrite letter A? Letter A says 9.9% of 5,987. How would you rewrite this to estimate this quickly? This is really similar to calculating sales tax or calculating tip. Percentages, super important to know, super important to practice, just so we can do it mentally and not have to take out our calculator every time, spend that extra physical energy. Just use our brains, right? Use our brains. What could we do here? And let me show the chat again so that you can all see everyone's answers here. 9.9% of 5,987. What would you approximate each of these numbers to so that we can get to the answer as quickly as possible? Gibby, great. Look at that. Right on cue. Amazing work. We have 10% of 6,000. Let me know if you agree in the chat. 9.9%, it is very, very close to 10%. Great, Olivia. So I'll write 10% of 6,000. Okay. How do we rewrite 10% as a fraction? Well, let me give you a little mini lesson here. Percent means per 100, right? Per 100. So 10 per 100 of 6,000. And that's how we know 100 cancels out and 60 times 10, as Gibby told us already, is 600. Now, this is an estimate for 9.9% of 5,987. If you plug that into your calculator, I guarantee you will get something super close to 600. And 600 will possibly be an overestimate of your actual answer, but still really, really close to what the actual answer is. And this is the power of estimation, the power of mental math, the power of using our brains rather than a device. Let's try letter B. Now, letter B, this type of expression is the exact type of expression that you would probably struggle with plugging into a calculator. You may make a mistake in misinputting one of the operations, misinputting one of the numbers, the decimal places, decimal points, and things like that. So let us estimate each of these numbers. 31.2, what would you estimate that to? 68.8, what would you estimate that to? 4.13, 2.12. What should we estimate all of these little numbers to? Okay, wow, Captain Jokovic already got 5. Amazing work. Let's see if you got any close to our estimate together. Let's go step by step, right? I don't want to skip too many steps here. Maybe you've seen this already, but pre-algebra is for those of you that are in 6th, 7th, and 8th grade before you head into Algebra 1 in 9th grade. Just a little plug, I do teach pre-algebra, Algebra 1, geometry, and Algebra 2. And this is pre-algebra today. And this is one of the very first lessons in the first month of my course, starting on October 6th. So let's take a look at this. 31.2, I can estimate to 30. Feels like a lot of you are just doing this all on your workbooks. 68.8, I can estimate to 70. Again, to one significant number, right? Or one significant figure. 4.13 can be rewritten as 4, and 2.12 can be estimated to 2. And now let's work on this. 30 plus 70 is 100. The square root of 100 will just be 10. 4 divided by 2 is 2. So 10 divided by 2 is 5. And that is going to be a great estimate to this expression right here. Without making any errors, right? Without making any operational errors while plugging into our calculator. Now, C, another simple one, 9.9 squared. What can we estimate this to? What can we estimate 9.9 to? Well, that might be an easy question, so let's do that together. 10 squared. And 9.9 is actually exactly equivalent to 98.01. And that's really, really close to 100, right? So when we want quick answers, When we want quick answers, trying to save time, we just want to get a rough estimate about things. And that's often how things work in the real world as well. They're like, quick, give me an estimate for how much this might be. Quick, give me a quick estimate about how much of this we need. Things like that. Estimation, super, super powerful. Let's keep it rolling. Estimating roots. Ooh, okay. Now, estimate these roots to one decimal place. Here we have the square root of 3. How should we estimate these roots? Any ideas in the chat? We have the square root of 3. How would we estimate the square root of 3? And it says to one decimal place. How in the world would we be able to estimate this? To one decimal place. Seems pretty tough, but I think we can do it together. We're working with roots. We have the square root of 3. Let me help you out for those of you that are thinking. What roots do we know? Right, let's start there. What roots do we know? For sure, what roots do we know? We have the square root of 3. And what are some numbers that we know the root of that are close to that number 3? Maybe on either side. That might work, right? Maybe on either side of the radical 3. Any numbers that we know are perfect squares around radical 3. Great idea, Kervin. We have 1 squared and 2 squared. Amazing. Another way we could write that is radical 4 or radical 1, right? And we know radical 3 is right in between radical 1 and radical 4. Great, Captain Jokovic. Now, how close is 3 to 4 and how far is 3 from 1? Let's take a look. I'm going to do this in a different color here. Between 1 and 3, they are 2 apart. And between 3 and 4, they are 1 apart. So now, in total, 1 and 4 are 3 apart. Now, if you think about 2 out of the total distance of 3 between the 1 and 4, that's 2/3, which is approximately 0.67. And to one significant number or figure is 0.7. So cautiously, I'm going to guess, since this is 1 and this is 2, I'm going to guess that radical 3 is approximately 1.7. And now I want you to check. What is the square root of 3? And give it to me in the chat. What is the square root of 3? Maybe give me a couple decimal places afterwards and let me know in the chat. See how close we got to the actual value of radical 3. Now, radical 3 is what we call an irrational number. It's a number that does not stop, right? The decimals don't stop. They just keep going forever. We can't write it as a fraction. There's no way we can write radical 3 in terms of a fraction. That's why we call it an irrational number. And we just approximated it. We just approximated a root, by the way. That's amazing. Radical 3 is approximately equal to 1.7. And if we put this into a calculator, we find that it is radical 3 is approximately 1.73. And let me get a couple more here. 1.73. Oops. 1.732050808757. All right, so we just estimated it and we got super duper close, right? 1.7, our approximation is so close, right? This is the power of estimation. Let's try the second one. B says the square root of 75. Let's use our same logic. Great, Olivia, and I love the participation, Captain Jokovic. What two numbers can we place between the radicals 75 to help us to estimate this root, root 75? What can we use? What two numbers can we use? What perfect squares do we know that are awfully close to 75? 75. The next number, if we keep going, 76, 77, not a perfect square, 78, 79, no, 80, 81, right? 81 is 9 squared. 81 is 9 squared. And let's go down. If 81 is 9 squared, let's try 8 squared, which is 64. And that's how I think, right? This is my thinking process. Between 64 and 75, they are 11 apart. And 75 to 81 is only 6 apart. So if we can think about 11 out of the 17, total, because 11 plus 6 is 17. Another way we could write this is 12 over 18, just to round. And 12 over 18 is 2 over 3. So again, 2 over 3 is approximately 0.7. So I can say, what about saying radical 75 is approximately 8.7? And now I want you to put this into a calculator and see what you get. What is the square root of 75? Curvin, great. 64 and 81, beautiful work. And I feel like you are not able to see my screen as well, so I will remove this chat for now, but that was fun while it lasted. Let me know if you want it back. But what is the square root of 75? Yes, 8.66025. And would you agree that 8.7 is so close to 8.66025? And if we were to round this actual value to the square root of 75 to one decimal place, this 6 would round the 6 in the 10th place up to 7. So this is the power of estimating, right? So cool, so useful, so quick, and it just makes us feel like we're doing this properly. This is also a lesson where I like to build good habits with mental math as well. Yeah, just like building mental math is so important in pre-algebra. Before we get into algebra 1, we're working with variables now. We're working with order of operations on either side of the equality. Right now, we're just working with single expressions. But this is building the foundation, right? If you stick with me through all these courses, I can guarantee you, wow, you're going to be able to achieve at the top of your class. Yeah, you're going to be up there. So let's keep this going. Let's keep practicing estimation and mental math. Here we go. Approximate each of the following. Now we have numbers less than 1 that we're dividing by. So it's going to get a little bit messier when we look at the expressions, but we can write them in a simpler in a simpler manner. So A, 20.45, I'm going to estimate to 20, and 0.49, I'm going to estimate to 0.5. Now, an easy way to estimate is to multiply out by 10 on both the top and bottom to get rid of this decimal point. And that will equal 5 on the bottom, because 0.5 times 10 is 5, and 200 on top. This gives us 40. If you were to put 20.45 divided by 0.49 in your calculator, you will get approximately, I believe, 41. And 40 is an awfully close approximation to this mess that we have as of a fraction. Let's try letter B. What would you rewrite letter B as to solve? How would you rewrite letter B? Let me know in the chat. How would you rewrite letter B? We have 52 times 6.78 all over 0.51. How would you rewrite that as we approximate this expression? For the first one, I saw the 20.45, so I wanted to estimate or approximate or round to one significant figure, right? We want one whole number and the others being zeros. So how could we do that with letter B? 52, pretty simple. 52, I can round to 50. Great, Captain Yokovic. It looks like you have already found the answer. Kervin, great idea. We can leave the 52 as 52 as well. That's awesome, right? I prefer to move it as 50, but I really like that you left it as 52 as well. It's not that difficult of a number to work with, but I really like that you changed the 6.78 to a 7 and the bottom one to a 0.5. Awesome work. Now, what I would like to do is I'm going to multiply both the top and bottom by a 10 to get this to. This is 350 times 10. That's 3,500 divided by 5, and that's just 700. So Jokovic, you may have missed the 10 in there somewhere, but all good. When we make mistakes and we fix those mistakes, that's when true learning occurs. And reminder, in my lessons, nothing is graded, right? You're not getting a grade for this. However, after the lesson, you are going to get practice problems. And those practice problems, after you solve them, you'll see what you have mastered, what you have gotten correct or incorrect. And I create detailed video solutions per each practice problem so that if you do get any of those incorrect, you can hit up those video solutions and it'll be another opportunity for you to master the concept and skills that we learned during that lesson before you come and join the next lesson. Let's try letter C. Letter C, let's do together. So 4.8, I can estimate to 5. Great, Olivia. Times 11.3. I can estimate that to 11. I thought about doing it to 10, but in this case, since we'd be subtracting an entire ones digit, I don't really want to do that. And I want to show you something really cool here as well. 3.28 minus 3.12, well, that's 0.16, right? This right here gives us 0.16, and I'm going to estimate that to 0.2. So now, watch what I do here. The 5 squared is great. I'm going to leave that. That's going to be 25. But for the 11 squared, I'm going to put a squiggly here because I'm going to estimate twice this time. This is the first time we're doing this, but I'm estimating twice now. 11 squared is 121, but I'm going to estimate that to 120 all over 0.2. I'm going to multiply top and bottom by 10, and this is what I get. 25 times 12 is 300. If you didn't know that, think about if you have 12 quarters, you will have $3. So $3 is 300 cents times a 10 and a 10. That'll be 300 hundreds all over 2, and that gives us 15,000. And that is our estimate for this mess. And I guarantee you, even with me explaining all the steps here, I probably did it faster than anyone that had to plug all that in into a calculator. Right? It's a super powerful, super powerful skill is estimation. That's what we're working on today, and we're almost there. Let's look at some applications of this. Penny has worked out this gross looking fraction on her calculator. Her answer is that 13,332.29917. Penny's answer is not sensible. Does not make sense, right? It's almost as if you saw the answer and you're like, make it make sense, Penny. It doesn't make sense. By rounding each number to one significant figure, work out a sensible estimate to show that her answer is not sensible. Let's do it. Let's prove her wrong. 81.2, I'm going to estimate as 80 times 59.2. What would you say that is? What would you estimate that to? 59.2 to one significant figure. Let me know in the chat. And if you have more time, also do the bottom one. What would you estimate 1.9 to? So this is kind of my check for understanding here before we get into the big practice problem. 59.2. Great. I see some 60s in the chat already. That is correct. How about the bottom one? 1.9. What would we estimate 1.9 to? Awesome. 1.9 to 2, right? 2 squared. All right, let's solve this. 80 times 60 is 4,800 all over. 2 squared is 4. So 4,800 divided by 4, that's just 1,200. So is 1,200, 1,200 close to Penny's answer of 13,332.29917? Ain't no way. So let's think about how to speak to Penny here. What do we think Penny did here? What's the mistake that we think Penny might have made? Great, Yogovic, I see you with the 2. What is the error that Penny might have made on her calculator? Well, let me tell you what I think she did. I think she did 81.2 times 59.2 divided by 1.9 squared. And what I think she did is she squared this entire thing without even knowing it because she forgot to put parentheses. And that's another thing. Oftentimes we forget to put parentheses around the entire thing that we're dividing, right? Or maybe she wrote 812. Yeah, that's a wow, great point, Yokovic. Maybe she forgot the decimal place, right? That's another thing that could have happened for sure. Great suggestion, right? Love the participation there. Yeah, so Penny could have done a number of things incorrect. And that's why when we use a calculator, oftentimes I see students make a lot of errors in their using their calculator. This is where estimation comes in. And what the power of another power of estimation is when you're making sense of your answer. Let's say you get to an answer. You're not done, right? You have to check that your answer makes sense given the problem. And in this problem, we are working with 80, 60, and 2 squared, which is 4. 80 times 60 itself is 4,800. Divided by a whole number 4, we should be getting smaller, not bigger, to 13,000, right? That's how we know this answer doesn't even make sense, right? This is how we know Penny didn't check her work, right? So another huge value and advantage to knowing how to estimate, checking our answer to ensure that our answer makes sense. Okay, here is our application problem for today. This is the big one. If you got this one, you know how to estimate. You've mastered today's concept and skill. Let's take a look. I love baseball, being born and raised in Koreatown, Los Angeles. I'm a huge Dodger fan, so go Dodgers. I think they're playing tonight. Hopefully they win. But let's take a look at this one. For a baseball game, 19,763 tickets were sold for $93 each. 26,235 tickets were sold for $207 each. Yes, baseball games are very expensive now in LA because of all the money that's being spent on the players. Work out an estimate for the total amount of money paid for these tickets. Let's take a look. What would you estimate 19,763 tickets to if you were trying to do this just in your head? Try to find a quick, rough estimate to see how much people have paid for all these tickets. What would you estimate 19,763 to in the chat? I'll give you some time to think about this one. $19,763. Great, Kervin. I see you with that 20K. Yes, I would do the same. 20,000. And I see a couple others have that 20K as well. Awesome. How about the $93 each? What would we estimate that to? And we want to be smart about this, right? We have 4 numbers that we're working with, so we want to make them as friendly as possible. What would we change that 93 to? All right, Jokovic caught 78,000. Interesting. Where did you get the 78,000 from, Jokovic? 100. Great idea, Kervin. Times 100. Great. And that's equal to 2 million. Let's do the same with this second line. How about 26,235? What's a nice number that we can estimate that to? 26,235. It's a nice number we can estimate that to. Oh, 78,000 total. Really? Does that make sense? Let's think about it, Yukovic. If 19,763 tickets were sold for about 100 each, that's already almost a million or 2 million, right? 78,000 would just be 19,763 times 2 or 3, right? Right? Or 4. 30,000. Okay, Kervin, I like where you're going with this. I like the 30,000, but keep in mind, how much did we estimate the 19,763 to? So this is where we start thinking a little more. I love that you came up with the 30,000, one significant figure, but in order to get a slightly more accurate estimation, what's another number we can estimate 26,235 to? A slightly more accurate, right? Because from 19,763 to 20K, we only had to round up 237 tickets. But if we go from 26,235 to 30K, now we're adding on 3,765 tickets, which is a lot of tickets, right? So our estimate might be a little more off than we can make it. There is still a nice number that we can use to estimate 26,235. And I can help you out with that. 26,000, love that. But what about 25,000? What do you think about that? Carvin, I love this thinking that we're doing together, because now the next time you see something like this, you're gonna get it like that, right? 25,000, right? We're comfortable working with quarters, right? 25, 50, 75, 100, right? We're comfortable working with 25. 26, not so much, but I like how you went from 30,000 to 26,000, right? We're thinking. Now, 207 each, this one's a little easier. What would you estimate 207 to? Anyone that's in the chat today, what would you estimate 207 to estimate the amount of money paid for 26,235 tickets sold for $207 each on average? Yes, 200. Awesome. So now if we multiply these two numbers together, 25 times 2 is 50. And we have to tack on 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5. And that is 5 million. So an estimate for the total amount of money paid for these tickets will be these two numbers added together, and that would be $7 million. For those of you that are in the chat and have access to a calculator, I'm sure some of you already have your calculators open. Go ahead and try multiplying these numbers out. Let me know what you get in the chat. We have 19,763. Let's see if you can get it faster than me. Times 93 plus 26,235 times 207. Wow, that is a big number. 7,268,000. What's left? 604. Would you agree, without having to type all that out and possibly making a mistake in the calculator, boom, our estimate is so close, right, to the actual number, 7 mil, right? This is the power of estimation, and I hope you had fun learning it today. And if you did, and you're still here, go ahead, put a plus in the chat or a W in the chat. I have something super exciting to share with you. Call your parents over right now. This would be the time. We're going to talk about how you can join my course. Our lesson may be ending, but your progress doesn't have to. At my Space, my pre-algebra full year course starts on October 6th. So a week and a half from now, pretty soon, if you think about it, a week and a half from now, the My Space Pre-Algebra full year course is starting. You'll get 2 of these engaging live and interactive lessons each week. So the lesson that you had right now, 2 of those like that each week starting on October 6th. All lessons are recorded. So if you have any family events, emergencies, extracurricular activities, anything like that, all the lessons will be recorded, and you can revisit and review them at any time until the end of the school year in June of 2026. Every lesson comes with a professionally designed workbook so that you don't have to copy down any of the questions. You can just focus on the learning. And after every lesson, you'll get practice with exam-style questions, 5 total questions that you'll be able to prove your mastery in. After you solve those problems, you can check your work using those detailed video solutions, and that'll act as basically another lesson on top of the lesson that you just had before you tried out those practice problems. So amazing value. But how much is it? For context, when I used to be a private tutor, how much do you think I used to charge per hour? And let me know your guesses in the chat. I started tutoring in high school. I did it pro bono, meaning for the public good, so volunteering. But in high school, all I could really help with is like homework help, right? Or solving problems that students didn't know how to solve. And when I used to tutor in college, I used to charge about $30 to $40 an hour because I was a math major at UCLA. I had those credentials. However, I again, still homework help, preparing help for exams and things like that. But I didn't know what the teacher was going to be teaching next. I didn't know how to prepare them, things like that. So affordable, but not effective. And now, after 7, 8, 9 years of teaching, how much do you think I used to charge per hour? I used to charge a minimum of $100 per hour because now I know exactly what's going to be coming up in your classes. I know the type of problems that you're going to be getting on exams. I know the types of problems that are going to be on your homework, right? I know all these things now. So I did charge quite a bit. And that's the problem with private tutors. Families have to choose between what works and what they can afford. Private tutors are not sustainable, right? They're not affordable. However, they are effective. However, if your tutor is affordable, they're probably not as effective. And you can never get both. That's why we created MyEdspace. You get all this for $99 a month, which is 8 times cheaper than what I used to be charging. I heard somewhere, I was calling a parent today, they were paying $80 an hour for group tutoring at Mathnasium. Um, wow, $80 an hour. You get 8 lessons for $99 a month with me at MyEdspace. And why stop there? If you're able to purchase the entire year package, $99 a month for 8 months is $792. But with a 20% additional discount, it would be $649, which means for 60 live lessons, you're getting each lesson for less than $11 an hour, which is insane and extremely affordable. And that's why we created MyEdspace, right? To make effective expert teaching not only accessible, but also affordable, right? And to protect you from any risks, we provide a 30-day risk-free full refund guarantee within the first month of lessons. If you're not, satisfied with the results, I mean, a month is not a long time, but if you're not satisfied with the lessons, then yeah, full refund guarantee. This is a first come, first serve basis. This is a limited time offer. So if you're interested, text me code word START to my number 512-900-1283. You can also scan that QR code and it'll prompt you to get right on to that text. And all you have to do is press send so that you can text that code word START to get that 20% additional discount on the annual package. Yeah, so text me if you were interested or enjoyed today's lesson. These are the types of lessons you'll be learning with me in pre-algebra. After my pre-algebra course, you'll be ready for Algebra 1. So this pre-algebra course is for students in 5th, 6th, 7th, and 8th grade. I say 5th grade because if you take this course, and a lot of middle schools offer placement exams for math. Maybe you'll place into Algebra 1 and you'll be taking Algebra 1 as early as 6th and 7th grade. Accelerate your learning. Why not get as many college credits as you can while you're in high school as well? So by the time you get into college, like for me, I took a lot of AP classes in high school. I entered UCLA at sophomore standing. So I was able to get the classes that I wanted, whereas a lot of my peers that were in freshman standing, all the classes were booked before by the time they had access to certain classes. So huge advantage there. So yeah, I look forward to speaking with you. If you enjoyed today's lesson, put W's in the chat. And yeah, I'll hope to speak to you via chat, via call, whatever it is, and hope to see you in my course on October 6th. Have a great rest of your evening, everybody. Thank you for your time.